So now let's begin with loops and jumps. So let's talk about first of all loops and jumps. And how do they work? So first of all, the very first instruction is JMP. So what it does, it's as it says here, unconditional jump, unconditional jump. So whenever in the code where it says jump, it will jump to this label. Now what is a label? So in a code, so here you can see, so in a code we can write such things. These are called labels. And so here if we write jump finish, it just jumps to this label. So this is the label, and then it starts executing whatever the code is within that label. So in this case, it's finish. So yeah, this is unconditional jump. It just jumps directly to finish. Jump label. This is the syntax. Here it will always be the label. Now let's talk about conditional jumping. Conditional jumps. So conditional jumps. Uh, the conditional jumps, as the name says, depends on the condition. And to check the condition, we use this instruction, which is CMP. What it does, it compares whatever that is written in front of it. So for example, operand 1 and operand 2. Now on the basis of this condition, it generates a result, and on the basis of the result, whatever we want from the result, we create conditional jumps. For example, if we want these comparison is if they are equal. So what we do, we write jump if it's equal. So jump if it is equal, yeah, and these are the rest of the types of the jumps available. For example, jump equal or jump not equal or jump lower or jump lower or equal or jump greater or jump greater, or these are the usual that we will use. These are all the usual that we will use. Mostly jump equal, jump lower, or jump greater. And note that they are signed. So that's we will mostly use signed because that's what we will be dealing with. Because using unsigned might create some errors because there are always minus negative signs. So it's always better to use jump lower or jump greater. Yeah. So on the basis of this comparison, we create these jumps. So one of the example can be if we want to see if EAX is negative. So what we do is compare EAX with 0. So here, if the EAX is less than 0, so JL, that is J lower, if EAX is lower than 0, jump to negative label. And for example, negative label can do anything here, negative, and there can be its code. This is an example of conditional jump. Yeah, here to compare EAX with 100 of hexadecimal. If it's greater, jump to branch B here. And if it's lower, jump to branch C here. And last is if it's nothing, it's if none of the jumps um, work, like none of the conditions are met, you can just directly jump to finish without any condition. And yeah, this is another example. JB and conditional jump continued. JCXZ. Now it's directly, if we don't want to use compare, we can just check this. So if CX is 0, it will jump to the label. Now CX register is from ECX. It's half of the ECX register. So ECX is this, and ECX is 4 bytes. So CAX will be 2 bytes. CX. So it checks CX, and this G JECX Z checks if ECX is Z. It is 0. That's the name. And another more important, more useful are not is another instruction, that is not instruction. So it's basically what it does is if you have in some EX register this 1010 for that is 4 bits. It won't be EX because what it will be is 8 bits, so 1 byte. So it will be AL, which is a 1 byte. So 101010. Let's just suppose this is AL, and we want to do not AL. So what will not AL do? There is a space in between. So not AL. So what it will do is it will swap every 0 and every 1. So instead of 0, it's instead of 1, it's 0. Instead of 0, it's 1, and so on. So 0 1 0 1 0 1 1 B. So not AL is basically changes. Um, it swaps everything, every 0 to 1 and every 1 to 0. That's not operand. Now, not instruction. Now, sixth is uh, test and test. They are similar. What and does is basically multiplies, you can say. So if and let's write and what we want to do is between 1 0 1 0 0 0 1 1. So this is 8 bits, that is 1 byte, and it should be between let's just suppose 0 1 0 0 0. It's 4 5 6 7 8. So what it does is basically multiplies. So each term with each digit of the first operand with each digit of the second operand. So the result will be stored. See, so result will be stored in the first operand. So instead of this, the result will be 0, 1 multiplied by 0 0, 1 multiplied by 0 0, 0 0 0 0 0 0 1. That will be the result. So basically multiplied each digits with itself. So this is the only one here. That's why this is the result. And test is works similarly, but it doesn't save the result. What it does, it um, raises flags. And flags is another thing. Flags is like kind of a alarm, you can say. So what for instance, test instruction always clears or oh. So it sets zero flag, S flag, PF flag. What are these flags? So SF is sign flag, PF is parity, and zero. Mainly it's zero flag what we are looking for. If the answer is zero, then the zero flag will be raised. That's where we usually use it. And there are specific use cases, but yeah, it doesn't save the result. It just raises a zero flag. That's the only difference. But and instruction saves the result as well as raises the zero flag. And zero flag is usually raised on is always raised only when the result is zero. So here zero flag is not raised. But if the result was zero, then the zero flag is raised. And if the zero flag is raised, we can utilize this flag in other instructions. For example, JE or JZ. JZ, what it does is if zero flag is raised, it jumps to the label. That's a specific use case scenario of test instruction. And we did test. Let's try OR. OR is basically logical addition. What it does is so 1010 1010B and 11000000B. So OR, what it does is just adds OR basically OR instruction. So if one or one, any out of them is one, the result will be one. So here one of them is one, so result is one. One of them is one, so result is one. One of them one is so result is one. Here it will be zero. Here one of them is one, so result is one, and similarly like this. But you can also do addition. So one plus one will be one because two is not possible, so we put it as one. And here 0 plus 1 is 1, 1 plus 1 is 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, and so on. So you can interpret it as however you want. I would say or is better, like if one of them is 1, that means the result will be 1. So that's how or works. And XOR. Now XOR is a slightly different version of OR. The only difference is that 1 plus 1 is not 1. That's the only difference. So if we run the same code, if we try to do the same thing, but with XOR, so here, if we try to do XOR, the only difference will be here. That 1 plus 1 is not 0. That's the only difference in XOR. Uh, XOR is useful when XOR is useful when we want to set something as 0. So instead, for example, if we want to set a register 0, so move EX 0. A better way of doing this is we put XOR EAX, comma EAX. What it does is creates this sets EAX to 0. XOR is mostly used here because in this instruction there is less data used, so less it will be quickly executed than this. That's why we usually prefer XOR EX to set the value of something, and for example, a register to 0. And a few more instructions are here. So ninth is bit operations, shift left or SHL. So what it does is shifts the bit to left, as it says. So if we want, if we have a byte, 1 byte, so usually AL we will use here because it has 8 bits. 8 bits basically shifts the bits to the left. And second is shift right, as the name suggests. Third is arithmetic shift right. What it does is saves the sign of the byte. But here it won't be saved. Here, if we shift right, the first byte will be question mark. It can have anything. But here, it will save the sign of it. So if it was 0, then it will stay 0. If it was F, which indicates that it's -1, then it will stay -1. And fourth is rotate. So rotate towards left. It picks up the leftmost value and puts it onto the rightmost. So rotate left and rotate. This won't be used very regularly, but still good to know. That's basically it about jumps. Now let's look at loops quickly, and then we can try to solve the midterm questions. So loop. What does loop do? Loop. What it does is basically, so loop is based upon hmm, loop is works on. So if there is a label, so cycle label, and there is a code to do something like it says here. And if we write loop instruction here, cycle, what it does is jumps back to that cycle and reduces the number of times that cycle needs to be executed. The number of times cycle needs to be executed depends on the register ECX, as the name suggests, count. And when we learned about registers, we wrote down that this is usually used for counting or looping. So what it does is basically decreases the value until ECX reaches 0. That's when the loop stops. When ECX reaches 0, the loop stops and the code moves on to next of this level. So one of the things that we need to make sure is that ECX should not be 0 or less than 0. It should always be greater than 0. If it's not greater than 0, then this cycle will loop infinitely. It won't stop. It will only stop when ECX reaches 0. So this is one of the looping examples, and it loops on the array. Nested loops, so loop after loop. Yeah, now let's try to understand. Let's make a new page. Go to page 2. Yeah. Let's try to understand array. So how do we work with arrays? That's one of the questions in the exam. So should know about it. Array. So that's how we initiate array vect. So this is the array given, and what we do is start the code. What we do here is ECX. ECX is 8. 8 means counter, and C. So that's how many times it will repeat. And then move 0 to ASI, and ASI is source index. It will be used to for the index of this array. So here, if we try to compare vect, so what are we trying to do here? Calculate the sum of all positive elements of the given array. So here, we are doing is comparing vector ESI. So vector ESI. ESI, let's write it down everything. Let's write down ECX is 8, ESI is 0, EBX is 0. When we start this label A, we go to the vect, and vect is our array. You can see here it's our array, and ESI is 0. So what it will do is it will go to the 0th element of vector array, vect array. So this is the 0th element. So what it will do is it will compare it to 0. So it will compare it to 0. So here 1 will be compared to 0. If it is lower or equal, then we go to the next. So if it is lower or equal than 0, then we go to the next value. But it is greater than 0. If it's greater than 0, what we do is we move this value to AX. That means we get AX equals to 1. And then we extend AX to EAX with this CW, convert word to double word into EAX. So EAX will become 1. And then what we are doing is we are adding this EAX to EBX. That means our EBX will become 0 plus 1. And then we move on to next. And then this is ESI. Here, the reason why we increase ESI by 2, 0 plus 2, is because this array is every word is 2 bytes. So every word is 2 bytes. So here the first byte in memory. Let's see how it's saved in memory. So in memory, this will be 0, 1, 0, 0. It's swapped always. And then it will be, as it's a word, then every element of the array is uh, of 2 bytes. That's why we write it like this. And the reason we write it swapped is because it's in memory. And how we will write 2 then? It will be 0, 2, 0, 0, and so on. Now, the reason we add this ESI value with 2 is because we are moving to the next address, which is after 2 bytes. So because this is vect plus 1, this is vect plus 2. That's the reason why we jump to 2 values. So when we jump 2 values, then we will look for vect 2. When we look for vect 2, we'll get this value. And then we compare this 2 with 0. And if it's greater than 0, then we set AX to 2 and then EAX to 2. And then we add this EAX to EBX. That's how this concept is working. So you need to remember why we add 2 is because each byte, each element has 2 bytes. That's why if we want to go to the next element, we have to add 2 as the index. That's how we will be able to calculate the sum of all elements is how by exiting So JLE, if it's lower than 0, it just directly adds it and then loops it to A. But if it's not lower than 0, then it adds to the EBX value. That's how we are able to calculate the sum of it. So this is how array works. These are not really important. And then nested loops. In terms of nested loops, what we do is we have to save the value of ECX. That's we have to save the value of ECX with every loop. For example, here in this code, let's try the second example now. What we are doing is ESI. We are putting value of ESI is 0. That's what XOR does. Changes the ESI value to 0. So ESI is 0. EDI is 0. And ECX is 3. Now what is happening is in rows label, what is happening? Let's see what happens here. We push ECX. We push ECX. That means in top of the stack, we push ECX. ECX is 3. ECX equals to 3. Let's write it down. So ECX is 3. We push it on top of the stack, and then what we do is set AL equals to 0, and then we move ECX equals to 5. In rows, we move ECX equals to. In columns, what is happening is we push ECX. And what was ECX? ECX is 5 now, so it's 5. We compare MESI, MESI with 0. So current element of the column, is ESI. What was ESI? 0. So we begin with 0. We compare it. If it is we are counting. If it is not equal to 0, we jump to the next one. We jump to the next label and we add ESI to 2, and then we pop ECX, and then we pop loop in the columns again. So let's try to see. Let's try to loop in the column. So we pushed ECX to 5, then we compared the element of the column if it's 0 or not. So first column element is 0. So if it's not equal, we jump to next. So we jump to next if it's not equal. If it's equal, we increase AL. So AL we increase, which is AL will be 1 now because it was 0 before. And then we add ESI to 2. Now ESI will be 2. Then we pop ECX again. When we pop ECX, we will get ECX equals to 5. When we loop back to columns, what loop does is decreases the value of ECX by 1 to 4. We loop back to columns, and we keep going for we keep looping until the ECX value gets 0. And after column ends, what we do is we again pop ECX and we get the value for the rows. So yeah, that's how push and pop works. It's very important as we are able to save the number of rows by popping it into the stack, pushing it into stack and popping it again. And we pop it only after all the iterations of the column are done. Then we go with row again, and in that each particular row, we go with the columns again. So it keeps on going until all, especially this 3 reaches 0 until the number of rows reaches 0. That's how loop works. This is not important. Yeah, that's basically it. Let's try to let's try to use let's try to solve test questions. So here, task one, let's try to solve. So what AX will be after? So what we are trying to find AX in hexadecimal. AX has 2 bytes because EAX has 4 bytes and AX is half of it. So what we are doing here is we have an array given. You're starting the procedure and we are moving ECX. So ECX will be 4. Let's write ECX as 4 and ESI as 0 and AX as 0. So now what happens in label M? We're comparing with 0. Comparing comparing the zeroth, the value of ESI, zeroth element of vect word. So this vect array. So we are comparing. So if it's greater or equal, then we go to next. If it's not equal, if it's not greater, then we just add it to AX. So what happens here? So we can see that it's not greater. So it will be my AX will have -1. And if it is greater, then it just goes directly to next. So what we can see, if the value of the uh, element of the array is greater or equal to 0, it directly jumps. If it's not greater than 0, then we add it to AX. So we are adding the negative values to AX. So -1, let's just directly add all the negative values to AX. So -1, -3, and -6. And this will give us -9, -10. It's greater than or equal to 0, then it's next. It's not greater than or equal to 0, then we add it to AX. So it will be -10. And what's the value of -10 in hexadecimal? -1, -4. So when we try to convert it into hexadecimal, 10, F, first of all, we write 10 in terms of hexadecimal. Let's write it in terms of hexadecimal. 10 is A. We subtract it from F, 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 because that's our AX value. Wait, so AX has 0, 0, 0, 0, 0. Then we are subtracting from there and we get the value -10. So let's try to calculate this. F is 16 minus 10. 16 minus 10 is 6. It will be 6 here. F, F, F. Where is the answer not matching? Just a second. So one important detail that we missed here was just a second. One of the important details we missed here was that the loop can only run 4 times. So 0, 1, 2, 3, 4, or 1, 2, 3, 4 actually. So it will only count -1 and -3. Won't even count the other values. That's a good question. So it will be -1 and -3. That's why the answer will be -4. It's y. Minus 4, we can write directly as 4. So f will be, so see, 16. Oh, I did the wrong subtraction. We used to subtract with zero zeros. So 0, 0, 0, 0. What we are trying to get is minus 4. So 4 here. We write 16 here, 15 here, 15 here, and 15 here, and then 0. 16 minus 4 is 12. And 12 is, so A, B, C, 10, 11, 12. So C, F, 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 because 15 is F. So the answer is F, 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 C. That's why it's like that. Now let's try task 2. It's the same type. So what's the result? This is again the array given, and here again 4 times value of ESI. Yeah. So what we are doing is the X, yeah, and the L. Okay, so ECX is 4. That means it will run only 4 times. For 1, 2, 3, 4. Or okay, let's try this. So ECX. So move ESI is 0 and AX is 0. So M. So M is our main loop that we'll be doing. So AL, we are adding into AL the value. First of all, ESI value at 0. 0 is minus 1, so AL is minus 1. And then we increase ESI, so ESI plus 1 is 2. Then we loop back. That means ACX is minus 1 now. And now when we loop, so value is 2 here, so plus 2. And then we ESI plus 2 is 4. And here these values are stored into bytes. Very, very important detail. Here, when it was stored in Word, every we were able to loop through every it was stored in Word. That's why we were adding plus 2 because there were 2 bytes. But here it will skip one of the, so for instance, let's try to visualize this in minus 1, 2, minus 3, 4, 5, minus 6, 7, 8. So when we did ESI 0, plus minus 1 here, and when we do plus 2, 0, 1, and 2, then it will be minus 3 here. And then again plus 2, when we did plus 2 and then we looped back and minus 1 again, then it's 2 times left. So AL minus 1 minus 3, then what we do is plus 2, so plus 1 plus 1 plus 2 plus 3 and plus 4. Now what we are doing is adding 5. Now after adding 5 we add 2 again, and then we 4 minus 3, 3 minus 2 is 1. So now it's just one loop left. So value of ESI at 6, 5 and 6. So plus 7. And again we add plus 2 and we subtract minus 1. But now the loop it's 0 and there is no more plus 2 because this is 7th and this is 8th value. 8th value doesn't exist, so it won't happen. We cannot add anything. And then, yep, the loop ends because ECX is now 0. So the final result of AL is 12 minus 4, which is 8. And move result AX to, so full AX we move to result. So internal code of memory field. So in AX it will be saved as, so AX is 2 bytes, so 00 and 08. And in memory it will be saved as 08 and 00. That's the correct answer. That's the second question. We did first 4 tasks. Fifth we also did. We can do seventh as well. Jump. Yep. And eighth. Double what parameter? Oh, I see the zeros. Okay, eighth and ninth we might have. Yep, let's try now task number 7. Let's move on to the next page. That is task 7. Asterisk symbols in the text slide the missing. So what we are doing is number of stars we are trying to find in this, and we need to fill the write the missing instruction. So what is doing here is move, starting the procedure and move EX to 0. EX is 0, which will be the counter, how many there will be, and ESI is 0. So what we are doing is we are comparing the first character of the string. No. We are not comparing the first character of the string. We are comparing string, what is string ESI with 0. So we are comparing the element with 0. So if it's 0, we jump. If it's equal, so jump equal, we jump to done. The reason for that is because it means that it will stop at 0, but not at this character 0. It will stop at the number 0. So this is, you can say that this is an array with two values. First is a string and second is a number 0. So what it means here is that as soon as we reach to the last very last byte of this string, we stop. So how do we know we reached it? We compare it with 0 value. So that's why we are comparing it first, and when it's equal, we go to jump. And then we are comparing string with star if it's, so here it says next. So if it's not equal, then we go to next, which just increases the number, increases the byte, and then jumps back to check. So if it's equal, we increase the EAX. So what's happening here is if it's not equal, we are going to next. And if it's equal, we're increasing the EAX. That means that we are increasing the number of stars. That's why we wrote this instruction here. Now, what is eighth? Yeah, this eighth and ninth are from the last topic. Let's do the task 10. Array of 5 integer is defined. Each of the 5 is 5. Okay. So it's defined. Let's try x, and it's a word. That means each of the uh, element in array will be stored in 2 bytes. -1, -2, 42, and 0. That means if we just try to write it normally in 2 bytes, every character, so it will be 0001, and the second number is -1. I will write it directly. So FF, FF, Minus 2 will be FF, FE. 42, I need to calculate. And 0 will be there. So 0, 0, 0, 0. 42, let's calculate. 42 divided by 16 twice, 32, 10. So it goes 2 times. The remainder is 10, so 2a. It will be 2a, and here 0, 0. So internal hexadecimal code of memory byte. So if we write this in memory, it will be swapped. Every number will have swapped bytes. It won't be like the whole. It won't be like whole array will be swapped. Just each individual value or bytes will be swapped. So it will be 0, 1 and 0, 0, and then it will this will swap, but this is the same, so we will write the same, and then this will swap. Oh no, this swapped. This was the first, and now this will swap. This is FE first, and then FF, and then it is 2A 0, 0, and last will remain 0, 0, 0, 0. So as you remember, this is x plus 1, this is x plus 2, this is x plus 3, x plus 4, and x plus 5. That's what it's asking us. The answer is x plus 5, which is F. So we have covered uh, first 4 topics. Last topic is easier. I might not make a video for this, but yeah, I will put it if I do make it. Anyways, that's basically it. I might make a video, and if I do, I will also show more sample questions. I might show more sample questions to try. That's all.